Hey guys, HackerSploit here, back again with another video, and in this video we are going to be looking at the KRACK attack. Yes, we are finally going to look at the KRACK attack. More specifically, we're going to be looking at how to test different Android devices to see if they are vulnerable to the KRACK vulnerability. Now, some of you might be saying, well, Alexis, I thought you were going to show us how to exploit the KRACK vulnerability. Well, the truth is, I would love to have shown you this, but there aren't any KRACK attack exploitation scripts. There are the proof of concept scripts or the video, released by the original author or the person who found this vulnerability. But for the purpose or the security of the industry, or, for the goodwill of the industry, no attack scripts were released to the public. Essentially what the developer said is that he does not want to release a script that can be used negatively to affect organizations, etc., etc. So what he did release are the proof of concept scripts that allow you to test to see if your devices are vulnerable to the key reinstallation attack. Alright, and that's what we're going to be looking at. Now, a lot of you actually have tried to do this, but for some reason it didn't work for you. Alright, so let me explain my environment to you. First of all, when it comes down to the wireless adapter, I'm not exactly sure what adapters work and the ones that don't, because some of you have been able to have success with the internal ones, but for the most part, you guys wanted me to show you how to use these scripts to test to see if the devices are vulnerable to the vulnerability. All right, so I'm using a TP-Link TP-Link TLWN70. I'll leave the link, or I'll bring up an image of it. It is the version 1, and this is pretty much the standard when it comes to to one of the best WPA2 wireless adapters, USB wireless adapters. When you talk about network penetration testing, and I'm sure you know about this, luckily I was able to get my hands on the version 1, which allows packet injection, but I'm not exactly sure what the compatibility list is in regards to wireless adapters. Now, as for the GitHub repository that contains the scripts, I will be linking this in the description. You can see that this is the author right over here. Van Hoffem. I'm not sure if I pronounced that correctly, but there you go. And I'll be linking this in the description. Now, when it comes down to testing clients, it'll give you a very vague idea of how to do this, and I'll show you the way that works probably in most scenarios. All right, and what will happen here is I don't know if he did put the correct whether he did list the Wi-Fi adapters that will work, but in any way, you don't need to worry about that. I know if you have some of the ones that support packet injection, that'll work just fine. All right, so what you want to do is you want to clone this repository, and you can just use the clone and git clone from the terminal. So really simple. Just open up your terminal, and you want to go into your desktop like so, and git clone, and you want to paste in the link right over there. Now, in my case, I already have cloned the repository, and I'm just going to change into my folder, so KRACK, and there we are. We have the KRACK attack script, so I'm going to change into the KRACK attack scripts directory like so. And now, if I list the files and you do too, pretty much nothing should be different from the what mine is. Now, before we actually get started, we must understand what the key reinstallation attack is, or what the vulnerability is. All right. So, and to understand that, we need to understand the WPA2 handshake. All right. So let me just explain that for you. And to do that, I have the help of an image, which many of you guys actually suggested that I should use images in videos where I have to explain a lot of concepts. All right. And this is a simple image that essentially demonstrates the four-way handshake that goes between the access point and a client, all right, during and after authentication. All right, so I'm going to explain a bit of these terms. So the first thing you need to understand is, what does PTK stand for? The PTK stands for the pairwise transient key. All right, and this is essentially used for the encryption process and is comprised of 5 attributes. All right, you have the pairwise master key, which I'm not going to explain right now, probably in another video. And you have the nonces, and I'm guessing you know that their MAC addresses are involved, as the MAC addresses essentially have to do with media access control. Alright, so let me explain a few things here. The AP stands for access point. STA essentially stands for station, or you can say client, whatever you want to call it. The nonce, I'll explain that in a second. What else do I need to explain? Yes, what does the MIC stand for? The MIC stands for the message identification codes. And again, I used to prove, or actually used for the, for authentication and to prove authenticity of the packets that are being sent back and forth. Alright, they're not, they don't have anything to do with the encryption process. Alright, so, the PTK stands for the pairwise transient key. I've already explained, and then, you can see it tells you that, in the first case, the station constructs the PTK, which is then sent, we then have the message identification, which is then sent with the nonce created by the client. Alright, so I'll explain that in a second. Now, what's happening here? Let me explain the process. So the access point is going to transmit the access point nonce to the station or the client. Alright, the client then constructs the pairwise transient key and sends it with a nonce of its own that it generated, and it sends it with the, it essentially sends it with the message identification code for authentication. Alright, the access point, let me just enlarge this. If Kali Linux will let me do that. The access point then creates or constructs the pairwise transient key and sends it back to the client with a GTK. So what is the GTK? I'm not going to explain what it does, but the GTK is essentially stands for the group temporal key. Alright, which essentially allows the client to what's the correct word? To view unauthenticated traffic. I'll make a few videos explaining all of this, but for now, just let's keep it to that. And then finally, the client sends back to the access point an acknowledgement packet, and the authentication is complete, and the client is then free to use the network and, you know, to do whatever he or she wants to. I'm guessing there's a user behind the client. Alright, so that is essentially the four-way handshake. Now, when it comes down to the where the crack attack comes into play here, is the crack attack is essentially a sort of man-in-the-middle attack that during the authentication process that allows the blocking of the negotiated pairwise transient key and allows attackers to install their own pairwise transient key. And essentially it involves a lot of blocking of packets, and essentially the attacker is really forcing a key reinstall in the network, essentially cheating the access point or the client, whatever way you look at it, with the pairwise transient key. Now, as I mentioned, no attack scripts for this vulnerability have been released. Thankfully the developers of these scripts, or the person who found out, the researchers, for the betterment of, the world we live in, did not release any attack scripts, because there would be a lot of irresponsible people out there who would actually, go and start attacking networks, for the wrong purposes. Alright, in our case, we are going to be testing our devices, or, you can test your devices to see if they are vulnerable to the key reinstallation attack. Alright, so we are finally done explaining the four-way handshake. Now, let me just close that up, and we want to make sure we are in the terminal. So, the first thing you need to do, or you must do, is you need to install the prerequisites or the dependencies for the script to run, or for everything to run smoothly. Now, they do post them in the Github repository, so you can actually do that right now. You have it right over here, so you can install these dependencies. I already have them installed, but I can just do it to show you that I do. It'll probably just tell me to reinstall a few because there aren't any updates. So apt-get install, updated my repository, and there we are. So I'm just going to hit yes, and it's going to install. The two newly, so it's just upgrading them. So I'll wait for that to complete. And once you've installed the dependencies, we now need to start working with the host APD. All right, so I'll show you how to do that right now. And when working with the host APD, we obviously also have to compile it. This is where people had a few issues, and I'll show you what worked for me, and hopefully it does for you. Alright, and in addition, I have a few devices that are vulnerable to the key reinstallation attack, some Android devices. I'll be posting screenshots of me connecting, and I'll show you that in a second. They are older Android devices that are running, old versions of Android like KitKat, Lollipop, Marshmallow, etc. Alright, I haven't got the chance to try it on an Oreo device yet. Probably because my Nexus crashed on me, and yeah, it's just, it's in a boot loop, and I haven't had a chance to fix that. So yeah, that's also something that I'll be looking to fix. But that's for another video if I do eventually make a video on that. So now we have installed the dependencies. So let me just clear that up and let's list the files. So the first thing we need to do is you need to compile the host APD. So we're going to change our directory into the host APD. For some reason, Kali froze on me there. So host APD. And once in there, we're going to list the files, and I've already compiled my files. Now to compile it is really very simple. All we need to focus on first is the def config. We need to copy that into the config file. So if I list all the files here, and I just go to the top, we need to copy it into the config file right over here. And to do that is really very simple. So what we need to do first is we need to say config, we need to copy, and we're going to say def config into the, we need to copy it into the config file itself. So config, and once you hit enter, it's just going to copy it there. So don't worry about that. And once that's copied, you can then start compiling. And to compile, we simply type in make and j, make j and 2, and we hit enter, and it's going to compile. Now, of course, you are not going to have as many files as I do over here. That's fine. All right. But once it's compiled, you're going to have all of these files. Just give it a few seconds to compile, and you should be done. Alright, so once the host APD is configured, you now need to work with the configuration file, and I'll show you that in a second. But before we do that, we now need to talk about your wireless adapter. Alright, so your wireless adapter is going to be extremely important. Alright, so we'll go back and I'll show you what I'm talking about. Alright, so let's just go back here, and I'm just going to list the files in there. We want to go into the KRACK attack folder right over here. So change folder, KRACK attack. Like so, and I'm just going to clear the terminal, list the files in there. And now when we talk about the files that we will be using, we'll be using the cracktestclient.python file. Now, depending on the network adapter, the wireless adapter that you are using, you will face a few errors that might be demoralizing, but don't worry. If you are using any TP-Link adapter, I encourage you to run this script right over here, the disable hwcrypto.shell file, alright, or hardware the hardware cryptography shell script. So I want you to run that script. It's very simple. Just run disable the disable hardware crypto script, and once you've run it, it's going to tell you to reboot your computer. Alright, make sure you reboot it. Now you can see that if I type in ifconfig iwconfig, you can see that I have my LAN 0 here, and forget about this adapter. I'll explain that in a second. I have my LAN 0 there. I have my LAN 0 inserted, or it's active on my computer. And if you look at my network manager, I do not have it. I do not have it active. So that's the second thing you need to do, is to avoid interference. You want to make sure that your network manager, you want to stop that. So network manager stop, or you can use the service control manager to stop it. And now once it's stopped, now you need to actually change the interface you want to use in the host APD configuration file. To do that, I'm just going to open up the KRACK folder here, because I want to show you the actual editing. I'm going to go to host APD, and I'm just going to go to the host APD configuration file. And now you want to change your interface, which will be at the top right over here. You do not need to use the interface in monitor mode, or you do not need to change it, using AirMonNG. Simply change the interface right over here to your interface name, to your wireless interface name. In my case, it's WLAN 0. And once that is done, you just want to hit save. And once that's done, you're good. Now, when it comes down to the access point, that it is going to create. It's going to call it a test network right over here. And I believe the password is ABCDEFGH, which I'm not sure where it was printed. Anyway, that is the default password, which I believe you can change if you just go through the script, through the configuration file right over here. Alright, so you can configure the host APD configuration file the way you want it. And once you've configured and changed the interface name there, we are now almost ready to go. Alright, so we've successfully installed the dependencies. We have compiled the host APD files. We have now changed the host APD configuration file. And if you're running a TP-Link adapter, make sure you have run the disable the script right over here, the disable hwcryptos.shell script. If you're running an alpha device, an alpha wireless adapter, you do not need to run that script. Alright, so once we are ready to go, we essentially simply need to get started, and we can get started by essentially running the KRACK test client.python file right over here. So again, make sure your service, your network manager is stopped, and we're good to go. Alright, so I have my device in my hands right now, and what I'm going to do is I'm going to just run the script, the Python script. So KRACK test, test client.python file. I'm going to hit enter. Alright, and give that a few seconds to start running, and it should start telling you that the access point has been created. So you can see that, yeah, there we are. The access point has been created. And if it gives you the error if it gives you an error essentially telling you that, telling you to reset the PN4, to reset the PN4 GTK, don't worry about that. As I mentioned, the whole idea or the whole process is to do with the, with the authentication process. But again, do not worry about what that means right now. If you want to know what the GTK means, essentially the GTK is to do with the group temporal key and the fact that you are able to access the network after authentication. In this case, this wireless access point does not have any internet connection. Okay, so yeah, it'll keep on giving you the error reset PN4, the group temporal key. So don't worry about that if you do get that error. Alright, so I'm on my device now, and I can see the test network, and I've connected to it. And as you can see, it's going to tell me that yes, DHCP reply, it was able to connect. And you can see that it's going to tell me over here we have reuse detected, which means that the client reinstalled the pairwise key. So I guess this device is not vulnerable to the KRACK attack or the key reinstallation attack. Let me now connect with my other device, which is my Android tablet, which I believe was vulnerable to this attack. But let me just confirm that right now. Alright, so I'm just going to connect to it right now. I'll probably post a screenshot. In fact, let me do that right now. I'm just going to post the screenshot right over here from my tablet, and I'm just going to post it as I connect to it. By the way, the password for the test network is ABCDEFGH. And I've connected, and as you can see, we have it over here. The client does not reinstall the group key in the four-way handshake, which again is a good sign, which means this device isn't vulnerable as well. Now, when it comes down to the device being vulnerable, as I've mentioned, this is different for every device, and it's going to keep on sending the four-way message, as you can see, where the GTK. Forget about the group temporal key. That is really dependent on your access point and whether or not you are using an internet, or you are providing internet access through the access point itself. Alright, so this is a fantastic way of testing your devices to see whether they are vulnerable to the key reinstallation attack. Let me know what you guys are able to find or are able to deduce from the script, if any of devices are. And what the patterns are in regards to the operating system. What is the most vulnerable operating system to this? You can also test your Linux. Devices, and yeah. So fantastic. So if I just connect here and browse again, I think I have one of my devices is vulnerable. So hopefully I can get to demonstrate that yes, there are some devices that are vulnerable to this. So I'm just going to try and connect and browse here. 1 second, let's see if this does work. For some reason, yeah, let me just connect. let me just see here why this is. I'm going to just disconnect and connect once more with the device. For some reason, yeah, the script failed, and I'm just going to run it one more time. This is probably because I exited. I'm actually emulating a device here, so just give me a second. I'm just going to connect to it right now. Apologies for the delay, and we'll wait for this. So essentially what we're looking for is the reuse. It's essentially going to detect a reuse, and that will mean that your device is vulnerable. So I've connected, and for some reason it doesn't seem to be vulnerable right now, which is weird because I actually tested this device, or I'm not sure what error I got. Again, let me just test the other device that I have here, which is weird again, as I mentioned, because one of these was actually vulnerable to the attack. But if they aren't, well, I guess that means that I have some really good secure devices here. Anyway, that is simply how to test your devices, for the key reinstallation attack. Let me know what you guys are able to find out, or let me know what you guys are able to find with the script yourselves. And yeah, if you have any issues, just let me know in the comment section, and I'll be sure to help you with configuring the script. That being said, that's going to be it for this video, guys. If you found value in this video, please leave a like down below. If you have any questions or suggestions, let me know in the comment section or on my social networks, and I'll be seeing you in the next video. Peace, guys.